Alright, so now that we've worked on solving equations, we've done one-step and two-step equations, we're now going to work on problems where you have to solve for variables. So solving for variables means you get the variable by itself. Or I'm going to say get the variable alone. Remember, variable is just our word for the letters we see in our problem. So it's like any letter in the problem. A, X, C, any of those letters. So the steps to solve are the same as what we did in solving equations. You're going to try to isolate the variables. You want to undo operations to isolate the variable. So let's take a look at an example. We're just going to describe the steps. We're not actually going to solve this just yet. We're just going to describe the steps used to solve. And we're going to do the left-hand column first, and then we'll come back and look at the right-hand column once we get through the left-hand column. So if I was going to solve this problem, currently we're adding 7 to x, and then it gives us 19. So x plus 7 is equal to 19. To solve this problem, we would undo the adding 7. So the undo of adding is subtracting. So the step here in words is we would subtract 7 from both sides. And that's how we would solve it. We're not actually going to solve it on that one. We're just listing the steps. Let's look at another problem. Remember, when you have a number next to a variable or the letter, when they're right next to each other, this means multiplication. So to solve this, we want to undo the multiplication. So to undo the multiplication, we would divide by 2 on each side. Remember, when we say from both sides or on each side, that means on either side of the equal sign. You can kind of think of the equal sign as separating your equation into two separate pieces. So the undo of this is dividing by 2. Here's another example. We have x being divided by 5, and that's equal to 20. So it's asking us what number divided by 5 is equal to 20. To solve this, we undo dividing by 5, and the undo of division is multiplication. So you'd have to multiply by 5 on each side. Remember, we're just setting up how we would solve, we're not actually solving them. So let's take a look at this problem. This was our two-step equations because there's two operations going on here. We have multiplication with a number next to the letter, and we also have subtraction. So remember, when we're doing these problems, we always do PEMDAS in reverse. So now we're going backwards. So if we start with addition and subtraction, we're looking for addition and subtraction first. So I see subtracting 7. So the inverse of subtracting, or the undo of subtracting, would be adding. So you'd have to add 7 to both sides. Because remember, the goal is to get this 7 over here. So we're trying to move it and eliminate and get the x alone. So I'm going to write the steps in this one so we can see what comes next. 7 plus negative 7 cancels out, so I have 2x is equal to 26. Once you get to this step, this is why it's a two-step problem. Now it's just like what we did above in the second problem. This is a multiplication problem here. So to undo that, we would have to divide by 2 on both sides. Why it's important to know the steps is that you're going to see some equations that don't have any numbers in them. They just use letters. And those are called literal equations. So let's take a look at an example. So in this column, I have some other examples where I'm asking you to solve for a particular variable. So this is saying solve for x. So what that means is I want to get this x value all by itself. So look, these problems are very similar in how they're set up. the x is the first term, then they're adding something. In this case, they're adding whatever c's value is, and it's equal to something. And in this problem, it happens to be equal to p. So think about how we got x by itself in this problem. To isolate x, we subtracted 7 from both sides. So to get that x by itself, you would have to subtract 7 on both sides. So x equals 12. In this problem, it's a little different because we're not using any numbers, but the steps are the same. So if we know the undo of addition is subtraction, we're going to subtract the value that we're adding. So we want to subtract c from both sides. And you're probably saying, well, wait, you can't do that. That doesn't make any sense. But in reality, we're just showing the steps that we're taking. So for this problem, we would set it up the exact same way. I'm going to subtract c on both sides. C minus c would cancel, so I have x equals, and over here, these are not like terms, so I just write it down as what it tells me. P take away c. And that's how you would solve for x. You would have isolated x to get by itself. Let's try some more examples. So in this problem, we said our step was to divide by 2. So if we'd actually divide by 2, we would get x equal to 10. This problem is the same exact setup. It wants us to solve for b. So we want to get b all by itself. So we're looking to get b all alone. In this problem, we have two letters right next to each other. So when that happens, it means there's multiplication. So I have b times m. And we just said over here that the undo of division, or excuse me, the undo of multiplication is division. So I want to divide away anything I can from the b. So I'm going to divide away m on both sides. Because m divided by m would give me 1, and I would get b all by itself with 10 over m. So my step here was to divide both sides by m. And that got b all alone. Let's take a look at the next example. When we used numbers, we said we had to multiply by 5 on each side. So I'm going to multiply 5 on each side. 5 times 20 is 100, so I get 100 equals x. In this example, I want to solve for c. So c is here. So what's happening to the c? It's being divided by p. So just like in this example where x was being divided by 5, the undo of dividing is multiplying. So we're going to multiply both sides by p, because that was a number in the denominator. It's just like this problem, we're just using letters instead of numbers. So if I multiply by p and I multiply by p, p times h is equal to c. And so now you've solved for c. You've isolated c and got it all alone. Let's take a look at this example. Here we're solving for d. So remember we had two steps in these problems because there's two operations going on. There's multiplying and there's adding. So we need to work our way backwards. So we know the inverse of adding is subtracting. So what are we adding in this problem? We're adding the value of t. So we're going to subtract t from both sides. So if I subtract t here and I subtract t here, these t's will cancel. And I get 3d is equal to h minus t. It's the same exact thing we did in this problem where we added 7. But the issue with this one is that we can't combine those terms, so we just write down what we're doing to them. So now you get to this part, and this is to get the variable by itself, we divided because that's the undo of multiplication. So we're also going to divide here. We're going to divide by 3 on both sides. So if I divide 3 here, and I divide by 3 here, the 3 cancels, and I get d is equal to h minus t over 3. Because you can't simplify that. That's as far as you can go since we don't know the values for h or t. Okay, so there are 6 problems on the back. I'd like you to give them a shot and see how you do. I'll have the answers posted so you can check as you're working. Good luck.